Today on the show, we've got a look at running OpenBSD on an APU, some BSD in your Android, managing your own FreeBSD cloud service with Ansible, and much more. Keep it tuned to your place to be, SD. BSD Now, episode 171, the APU BSD Style, recorded December 7th, 2016. Yeah, I'm your host, Chris Moore.
And I'm Alan Jude.
I'm glad to have everybody with us this week. Another exciting week. We're getting close to Christmas here. I wore another Star Wars crummy t-shirt to go along with that. So, got to start a trend here. Keep it rolling. I saw I made some waves with the ugly Christmas sweater last week, too. Thanks, Alan, for changing the topic of one of our chat rooms.
That wasn't me. I think it was Glenn. It was Glenn that did that.
Oh, Glenn did it. Oh, crap. Well, anyway, I got to go find something else just as clever now. No pressure. But hey, we got lots of BSD news to get to this week. Lots of good stuff to talk about. So as we teased with the title of the episode here, we have some APU information, specifically with OpenBSD. Mm-hmm. So tell us what's going on here, Alan. I guess an APU 2 is what they're using.
Yeah, so this is up on GitHub. It's actually just a document that you can edit here. And it's a detailed walkthrough and write-up of getting OpenBSD running on the PC Engine's APU 2, which is one of these little tiny router box type things.
Sure.
The motivation is listed as, I chose OpenBSD because I have a few ideas of building a router that protects an IoT-rich network. So he's got the idea is that there will be many of these IoT type devices behind this router, and he wants to make sure that he can control the traffic that they're sending in and out of the network and easily inspect it. That's one of the main advantages of running something like an open source type OS on your router. Is it's a great spot to be able to run, TCP dump or Wireshark, such that you can actually see the traffic going back and forth across your network. Whereas, if you have a regular IoT device and it goes through your normal commercial router, you have no way of snooping on the traffic coming out of your smart refrigerator. And so
that's right.
There's really nothing more powerful than being able to run TCP dump on your router. And so that's the why they're building it this way. They say OpenBSD's combination of proactive security and a clean networking stack makes it possible to quickly implement this proof of concept. If anyone's interested in working on such a project, they should contact the author. It says some of the steps require downloading software. Wherever possible, you should verify checksums of such software, or better yet, download it from well-known repositories and so on. And then points to an article we will cover later on the show, Reflections on Trusting Trust.
Yes.
But then they give a breakdown of the all the pieces they used. So they have a little parts list here. So from PC Engines, they bought the APU.2C4, which is a little, I think it's AMD GX 412 TC quad-core processor. 8 gigs of RAM, has 3 Intel Gigabit NICs, 2 mini PCI Express ports, an MSATA, USB, and a real-time clock battery. And that's pretty slow. That costs about $122. Then they got the enclosure for it, a little black enclosure that has the holes for the 3 LAN ports and the USB, etc. And that was $10. The AC adapter, 12-volt, 2-amp Euro, is $4.40. They got an SSD for it, an SD card, a mini PCI Express wireless card, the cable for the antenna, the actual antenna, a null modem cable, a USB to null modem cable adapter, and an 8 gig USB flash drive to do the installation from. In total, was about $200 plus shipping.
That's still less than some higher end consumer routers, even.
And
not bad.
Most of them don't provide you with 3 actual interfaces on the router. Most routers would only have 2.
True. That is true. Yeah, that's really nice.
This is when assembling the hardware, make sure you follow the instructions on the PC Engine's website. In particular, remember about the cooling, to ground your wireless card, and don't forget to install the SD card.
That helps, right?
Yeah. So then the first step is to set up the serial console. This is a note that the serial port settings on the APU2 as 15200 baud, 8N1, so 8 bits, 8 data bits, no parity, and 1 stop bit. So first you need to install the USB to serial driver on your machine so that when you plug in the USB device, it'll work. Then you plug in, if you're using, FreeBSD or OpenBSD, it should just be there. But on Windows and Mac, you'll have to install a driver. Then you plug the USB end of the USB to serial cable into your Mac or other machine. Then you plug the DB9 end into the no modem cable and that into the APU. Then connect the APU to the terminal. You can just run screen or CU or whatever utility you want and connect to the serial port. Then power the APU2 off and back on by pulling the plug and plugging it back in, and then you should start seeing output on the screen as it boots.
Very nice.
Now, the first thing you want to do on a brand new APU is actually update the flash. So the BIOS requires flashing the ROM, so creating a bootable USB flash drive. In this example, they just used a pre-existing image of TinyCore Linux directly from the PC Engine's website. It includes the flash ROM utility, but doesn't include any ROM images. So first you download this TinyCore Linux, which is an image called APU2-TinyCore. Then you download the latest ROM for your device. And then it says this is required for making the wireless networking work and for the ability to boot from the SD card. So then you want to take that image and put it on and add the ROM thing to it. Then eject that image, insert your USB drive, and copy
It's
the
nice
files
that
over to it.
you can do it from a Linux now. You don't have to go find some DOS or Windows type situation to reflash it.
Then you write the TinyCore Linux to your USB drive with DD, and then eject that, and now you're ready to update the BIOS. So you want to power off the APU2, insert this USB drive you created, make sure you have the serial console connected, power on the APU, then press F10 to enter the boot menu on the APU. From that boot menu, you can choose the flash drive, and then once it drops to your TinyCore Linux prompt, you can use the flash ROM utility and just tell it, hey, write to the internal ROM here and write this image, the ROM you downloaded from the PC Engine site. When verification is done, reboot, and it should be good to go.
Nice.
So then you want to build your custom install image of OpenBSD. So it requires tweaking some of the serial settings, or if you have OpenBSD 6 or later, then part of this is already done for you. But in their example, they were using OpenBSD 5.9. So you download the OpenBSD installer, make sure you get the file system image, not the ISO, then insert your USB drive and DD that file system image onto the USB, and then eject it. Then you want to edit some of the serial settings to make sure that it's using the right baud rate, because I think the default was 9600, and now this way it'll be 115.200. So you can enter these commands into the boot prompt when booting the installer, or put them in etc boot.conf so that they'll always take effect. And then it's just a matter of installing OpenBSD. So power off the APU2, insert the USB stick, power it on, press F10, choose USB. At the boot prompt, fix the serial settings, and then press enter to start the install, and then follow the regular OpenBSD install steps, which is just press enter a bunch of times, basically. Maybe answer some questions. And then once that's all done, when you boot it up, OpenBSD doesn't have the firmware for the wireless card. They don't ship the firmware. So they have a utility, fw_update, that will go and download the firmware for your card and load it in. So with these newer cards, instead of having flash built into the chip to hold the firmware, they expect the OS to just load the image at boot each time. This makes it much easier to update and so on. And mostly it saves a couple of cents on each wireless card, and that's how the wireless companies make money now. Anyway,
That adds up, you know?
Yeah, so this is using the 8th N, so I guess it's an 8th rows based NIC, and so just using the fw_update command on OpenBSD, and it will go out and fetch the right firmware for that and get it loaded up, and then you reboot, and now you can just configure a router.
Yeah, so you're pretty much just ready to go set up PF any way that you want at that point.
Yep.
Oh, that's pretty nice. Well, definitely take a look at that. It's very helpful when these guides have a very detailed parts list, so you can replicate exactly the experience that the original poster had here.
Yeah.
So
even,
of course,
for each part, they listed where they got it. Although almost all of them came from the PC Engine's website. And, you know, that helps save on shipping if you buy everything from the same place.
True. Yeah, definitely check that out. And, you know, we've mentioned this in the past before, but, you know, friends don't let friends use commercial routers. So let's just put it that way. Anyway, okay. Well, on to our next story here. So where the rubber meets the road. So we have Brian here wrote a little blog article talking about their adventures installing OpenBSD and Arch Linux on a new Lenovo X1 Carbon, the 4th generation Skylake, which is what I'm using here. So this is of interest. But they also detail why eventually they had to move away from their beloved MacBooks, with has a long description of the journey away from Apple that we've heard elsewhere from other folks as well. Things like, you know, all the dongles and how removing, I think the escape key was the last straw for him in particular. You know, dedicated VI users find that very annoying. But anyway, the journey begins here in this part 1 of 2 story about getting the new Windows laptop, of course, shrinking the partition and creating space for a triple boot install, which of course would be Windows, Arch, and OpenBSD. Brian then details, of course, how he set up the partitioning and performing the initial Arch installation, getting it tuned exactly to his specifications. So all that info is there. If you want to follow along with that and set up your own triple boot, you can do so. Next up was OpenBSD, though, which I guess he was trying 6.0 on it, but he said that initially went sideways due to the newer NVMe drive that wasn't fully supported yet. So the article is split into two parts. The next one should be posted here in the near future. But he leaves us with a plan of attack where he's going to be building a custom OpenBSD kernel with corrected PCI device identifiers. So hopefully that goes well and that results in a OpenBSD install in that box. But we wish Ryan luck. And of course, we'll bring you the rest of the story soon because I think there'll be others who want to do this kind of triple boot setup as well. I'm only doing dual on my X1 Carbon, but yeah, triple will be neat. EFI makes it really easy to do these kind of boot situations. So
I guess I had triple on my Lenovo for a while because I had the Windows partition for recording interviews, the PCBSD, and then TrueOS partition that had for working and doing presentations.
Yep.
And then back when it was new, I had a small FreeBSD partition for testing the EFI stuff and booting ZFS from EFI.
Well, that's cool. Well, again, we wish him luck, and hopefully we'll see the rest of the story here soon, how that gets solved. But I think a triple boot OpenBSD box sounds interesting, and I think many folks will find that appealing.
Yes. I think the other big one to watch out is he has his little pro tip highlighted in red about the device naming for the NVMe devices. They get slightly confusing because you have your NVMe device, like NVMe 0, then those have... regions, I think they call them. I forget what it is they call them, but an NVMe device can be broken up into different sets of flash. So you actually have NVMe 0 and 1, but that's not partitioned yet. So then when you partition it, you end up with NVMe 0, N1, P1, and N1, P2, etc. And he saw N1 and figured that was already the partition, and he accidentally overwrote everything with his encrypted Linux partition during one of his attempts. He had to start over.
Oh, that's a bummer.
Yeah.
Oh, okay. Well, good to know. I guess I didn't notice anything like that on mine. It didn't show up that way anyway. It just showed up as NVD 0.
Well, the confusing one on BSD is you will actually end up with two different devices. You'll have an NVMe 0, which is the control interface, and then an NVD 0, which is the actual disk. And if you have two chunks on one NVMe device, I think you'll have NVD 0 and NVD 1, even though you only have one cart. And so, yeah, on BSD it's done slightly differently. But
okay. Well, nice. Well, again, take caution there. Anybody who's going to try and replicate this. Okay, so we got to go to our first sponsor this week before we continue on with the news here. So the first one this week is going to be DigitalOcean. Of course, the website for that is digitalocean.com, and you'll want to go there and get your account created. Now, when you do so, be sure to go to the account section. Usually I forget where the link is now. It's been a while since I've done this, but there's the redeem coupon code where you'll type in FreeBSD Now. And don't forget that it's FreeBSD Now, not just BSD Now. When you type in FreeBSD Now, you'll be given a $10 credit, which is going to be good for, of course, running VMs. And heck, at $10, you can run one of their lowest end ones for 2 months straight for $10, which is amazing on an SSD, just super, super cheap. Yeah. But then, of course, if you want to rent them hourly, you can do that and stretch it out. Maybe you just spin up something a little bit over the weekend or whatever to do some tinkering.
Yeah, or in my case, it's like we're going to have a big live stream coming up this weekend. And so we needed a whole bunch more servers, but only for one day.
Yeah.
It's like, at 11.9 cents per hour, I can get a bunch of these machines with 8 gigs of RAM, 4 cores, 80 gigs of SSD space, 5 terabytes of transfer, all running FreeBSD, and I can spread them out across data centers all over North America. And it's like, okay, so API, click little for loop, click, 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 and there. I have 36 servers ready to go.
Yeah, it is pretty amazing how convenient they make that. Yep. Our next story is going to talk about actually building stuff or spinning things up in the cloud. I wonder if it could be adapted to do some DigitalOcean API calls.
We used Colin's config-init system to actually make our FreeBSD images. When we spin them up with DigitalOcean over the API, we give it a little config file, shell script thing, and it runs that on when it first boots. So it does the FreeBSD update to make sure our machines have all the latest security patches. Enrolls them in our config management system and starts all the stuff it needs to do, registers the host name in our dynamic DNS system so we know their IPs, and sets it all up, reboots. When it comes up, we have a fully going scale engine server, and it takes like 3 minutes.
That's just too easy, Alan. Yeah. It's so nice to have these things be reproducible. And of course, when you go on their website, check out all the locations around the world. Maybe you want something just down the road from you or something on the other side of the world. I know Alan's mentioned he uses it as a status server for a scale engine. And, I use it here for IRC bouncing, among other things, and mail server backup. But definitely good stuff. And you guys should get started today. And of course, FreeBSD is available there. Now they offer FreeBSD with ZFS. So if you want to run a little beefier VM with some more RAM, you can do that. If you'd run OpenNet, Dragon, you can do those as well. So there's instructions all floating around the internet how to set those up. So definitely give them a spin today. It's nice to see a cloud provider supporting BSD so well. Yep. Okay, so moving right along here, we know that setting up a FreeBSD jail server can be a daunting task to some folks. However, when a guide comes along that shows you how to do it, including not exposing a single non-jailed port to the outside world, we had to take a closer look. So the guide comes to us from GitHub, courtesy of Jorg Fielder, and the project goals listed on the guide seem very notable. He said, first up, it's an Ansible playbook that creates a FreeBSD server which hosts multiple jails. Travis is used and run and test the playbook. No service on the host is exposed externally. All external connections terminate within a jail. Roles can be reused using Ansible Galaxy, and you can combine any of these roles to create a FreeBSD server which perfectly suits you. Oh, that sounded very intriguing. So, of course, we had to dive in a little further. So to get started, you'll actually need a machine with Ansible, Vagrant, and VirtualBox, and your credentials to AWS if you want to automatically create or destroy EC2 instances. So I guess VirtualBox would replace that if you don't want to put them up in the cloud and host them yourself. But he's already got a very impressive list of Ansible roles created for you to start with. And just reading off the list here, we have a FreeBSD build server. So if you want to run Poudriere, for example, that's good to go. FreeBSD jail host. FreeBSD jailed, which provides jails. There's a jailed Nginx, PHP FPM, SFTP server, SSHD server, syslocd, BT Sync, Joomla, MariaDB, and WordPress. So quite a few things already ready to go and ready to be deployed. But since the machines have to be customized before starting, he does mention that they leverage Cloud Init to do some of the following steps. In other words, activate the PF firewall, add a pass all keep state rule so you can keep track of your connection states, which in turn allows you to reload the PF service without losing connection. That's an obvious one. Another thing is they install some packages, of course, so you'll need sudo, bash, Python 2.7, etc., and also allow passwordless sudo for the EC2 user as well. So that's all done in the cloud init step. But from there, it's actually pretty straightforward. Just a couple commands to spin up the VMs either locally on your VirtualBox host or in the cloud with AWS. So internally, the VMs are configured with IOCage to create jails, which is where all your actual services run. But definitely a neat project. You'll want to check it out today if you want a kind of a shake and bake type cloud/jail solution where you can deploy super easily. So again, really impressive, and hopefully more people find some use out of things like this. I think these are fantastic.
Yeah, what I found really interesting was the concept of having the jump jail in his little diagram at the top. So it seems rather than being able to access, so if you want to SSH into any of the service jails or whatever, you actually go to the jump jail, and then only from there can you get into the other jails. And I think that's an interesting idea.
Very, very cool. Yeah, I like that. Just it looks very clean and well thought out the way it was designed. So anyway, take a look today. We encourage it. Yeah. All right, so tell us about this next thing. We have some Android stuff to talk about. I don't think we've ever talked about Android on the show before. So this will be fun.
Android uses quite a bit of BSD stuff, including I think the libc on Android is from OpenBSD. But this is an article over on the official Android-developers blog from yesterday. And this post is talking about how they used BSDiff and BSPatch to reduce the size of Android application updates. So if you have an Android device, I'm sure you're familiar with the fact that applications get updated, often quite frequently.
They do.
So they have
more often than you want.
Yeah. So from earlier in the year, they have a post where they announced that they started using BSDiff so that when you're upgrading from version X to version Y of an app, it will use BSDiff to create a smaller archive for you to download. And with that, they were saving on average about 47% versus downloading the whole application again. With this new update that they've just posted, they now actually have them being 65% smaller. And in some cases, for especially smaller updates to app, it could be as much as 90% smaller.
Oh, wow. Well, it is only the changes, right? So makes sense.
And they explain how they got it. Went from 47 to 65 without actually having to change BSDiff. So, in case you didn't know, BSDiff is an algorithm developed by FreeBSD's Colin Percival, and it's how FreeBSD Update distributes updates for the FreeBSD-based system by having many small files by basically doing a BSDiff of each individual file. So, say earlier this year, we announced that we had started using the BSDiff algorithm by Colin Percival. Using BSDiff, we were able to reduce the size of app updates on average by 47% compared to downloading the full APK. This particular post that we're highlighting today is actually about the second generation of their code. They say, today we're excited to share a new approach that goes even further, file-by-file patching. So app updates using file-by-file patching are on average 65% smaller than downloading the full app, in some cases more than 90% smaller. So Android apps are packaged as APK files, which are actually .zip files with special conventions about certain file names existing. And, just like a FreeBSD package file is a tar.xz with a couple of special files in it. Most of the contents within the zip file, and APKs, are compressed using a technology called deflate. While deflate is really good at compressing data, it has a drawback. It makes identifying changes in the original uncompressed text really hard. They actually have a little GIF animation here. You can see a paragraph of text. Let's scroll here.
Yep.
Paragraph of text, and when you just change add one character to the second word, the compressed version changes almost completely.
Yeah, it's true. Compression will do that to you.
Yeah, and then you end up with a bigger diff than you need. So that even a tiny change to the original content, like changing one word in a book, can make the compressed output of deflate look almost completely different. Describing the differences between the original content is easy, but describing the differences between the compressed content is so hard that it leads to inefficient patches. So in the second generation of the code, instead of using BSDiff on the original APK and the new APK to generate a diff that saved them about almost half the bandwidth, they now...
Which still isn't too shabby.
They now extract the diff each individual file and make a new archive of just the diffed files, and using that, they're actually getting 65 to 90% instead of 47% savings. And, that's quite useful.
That's pretty amazing. Yeah.
And then they go on to say that with the current level of stuff that's happening, this is saving about, I think he said 6 petabytes a day in app downloads.
So that's real traffic, basically.
So fortunately, after analysis of the apps in the Play Store, we discovered that recent and compatible versions of Deflate based on zlib, the more popular gzip thing, account for almost all deflated content in the Play Store. In addition, the default setting of level 6 and maximum compression setting of level 9 are the only settings we encountered in practice. So they have more details on how it actually works in here in the article, but they have some examples like if you look at the Google Maps, the original APK is 32.7 megabytes. With one of the recent updates, if they had used the regular BSDiff approach, they would have saved 46%, and it would have been 17.5 megabytes. But when they did file-by-file patching with BSDiff, they got it down to 9.6 megabytes, saving 71%.
Wow.
Or the Netflix app, instead of saving 52%, they now save 92%.
Yeah, that's good stuff. Especially if you're updating not over your Wi-Fi, over your mobile network.
Yes, when you're paying for the bytes, you'd like to save as many of them as possible.
For sure.
What's also interesting is that BSDiff has been used in other places for quite a while. I know Firefox switched to it at like version 2 or 3.
It's been a while back. Yeah.
If you remember way back to when we first started using Firefox, if you were updating it, it involved downloading the entire, like if you use the updater built into Firefox on say Windows, it would download the entire new installer every time. And then one day, all of a sudden, they released much smaller patches. It turns out they started using BSDiff.
That's what did it.
And, there's also copies of BSDiff built into Chrome and Chrome OS and obviously in Android and so on. So that little bit of BSD licensed code has gotten to many, many places. So Colin has a dedicated website set up for BSDiff on his blog there. One of the interesting things he notes is that a far more sophisticated algorithm, which generally provides roughly 20% smaller patches, is described in his doctoral thesis. So he came up with BSDiff as part of his thesis when he was studying at Oxford for his degree or whatever. And the implementation that everybody's using is just a small one that he came up with back in 2003. It's been improved a number of times. He's up to version 4.3.
So it's time to update, man. That's 20% of how many petabytes?
Right. So in particular, no one has actually ever implemented the algorithm he described in his thesis.
Okay.
But if you're more interested, there's lots of math on this page. It actually describes, how much memory it takes to generate a BSDiff patch, and it's like at most it's 17 times n, or 9 times n plus m plus 01, etc. Yeah, lots of fun stuff there. But he says you can tell how old this was when BSPatch was first came up with. He says on a 200 megahertz Pentium Pro, building a binary patch for a 4 megabyte file takes about 90 seconds. That's a Pentium Pro is 200 megahertz.
That's true.
And using BSPatch on it takes about 2 seconds to apply the patch. Of course, now if you apply that to modern hardware, it's probably a little bit different.
Yeah, negligible. Yeah, that's amazing. Well, tell us about his observation.
He posted a thing on Twitter last night when, he got quite a few mentions on Twitter when Google posted an Android post. He had an interesting observation saying, I just realized that the bandwidth savings due to BSDiff are now roughly equal to what the total internet traffic was back when he wrote BSDiff in 2003.
That's pretty amazing.
Yeah. Thinking back to 2003, the internet did not have as much stuff going back across it. And now just what we save, because using BSDiff for like Android and Firefox and Chrome and a couple other places it's used, actually adds up to more than the entire bandwidth of the internet back when it was first come up with.
So what kills me is we have all this great tech and it's in FreeBSD. Why isn't package using it yet? Where's my Delta packages?
Well, Delta packages are harder because unlike the operating system, people aren't going to necessarily have P1 or P2. They're going to have one the package. The port tree gets updated. We build the new packages like every 3 days.
Constantly.
So it's like, well, we would need to keep a patch against each version from every one of the last 3 days.
Oh, yeah.
And
it would get out of control very quick.
With more reproducible builds, it would help because it would mean, the actual version of the package would result in the same thing. Right now, we can you could build.
You got to think, though, Google's the number of APKs floating around. How many older copies do they keep of that?
Right. Well, at some point, if you're updating many versions at once, then they're probably just re-downloading.
Mm-hmm.
But
Interesting.
They push pretty hard to have people download every update to Google Apps or Google Maps, right?
That is true. Yeah, the phone just kind of does it now half the time, without you even telling it to. Oh, okay. Well, good stuff. Well, thank you, Alan. Okay, heading over to the news roundup now. So first up, we have a story over at DistroWatch that Jesse Smith did. A pretty in-depth review of NAS for free. So I'll go over some of it and read his conclusions. But the review starts with mentioning, of course, that NAS for free works on 3 platforms, of course, ARM, i386, and AMD 64. And for the purposes of his review, he'd be using the AMD 64 builds. So he started off by doing the typical thing, going through the initial install, doing the typical disk management operations such as DPT, MBR, etc. He was then actually ready to boot into it and start using the product. He said one concern that originally he had observed was that the initial boot seemed really slow. A little investigation revealed that this is due to loading the entire OS image into memory. So the first long disk read does take some time, but once loaded, the UI is super responsive. So that's kind of cool. He said the next steps involved doing the initial configuration, which meant creating new ZFS storage pool. He said after this process was done, he did find one puzzling UI option called VM, which indicates that it could be linked to VirtualBox in some way, but he said the docs didn't reveal the secrets of his usage. So nobody's quite sure what that did yet. So maybe a NAS for free developer can write in and clarify that for him. But additionally, he covered some of the different access methods, of course, which is it's a NAS, so you got to have that somewhere, which included 3 tabs, so traditional Unix permissions, Active Directory, and LDAP. And then, of course, the varying sharing services, which are typical to a NAS, such as NFS, Samba, FTP, and others. So he covers that as well. But he said one neat feature was the built-in file browser via the web interface, which allows you another method of getting at your data when sometimes NFS or Samba or WebDAV just aren't enough, which is kind of cool. I do like that. And he gives us a nice roundup conclusion, though, which I'll just read for you because I think that summed it up pretty well. He said, most of the NAS operating systems I've used in the past were built around useful features. Some focused on making storage super easy to set up and manage. Others focused on services such as making files available over multiple protocols or managing torrents. Some strive to be very easy to set up. He said NAS for free does pretty well in each of the above categories. It may not be the easiest platform to set up, but it's probably a close second. It may not have the prettiest interface for managing settings, but it's quite easy to navigate. NAS for free may not have the most advanced services and access protocols, but I suspect there's more than enough for most. He said, where NAS for free does better than other solutions I've looked at is security. He said, I don't think the project's website or documentation particularly focuses on security as a feature, but there are plenty of little security features that I liked. NAS for free makes it very easy to lock the text console, which is good because we do not keep all of our NAS boxes behind locked doors. The system is fairly easy to upgrade and appears to publish regular security updates in the form of firmware. NAS for free makes it fairly easy to set up user accounts, handle permissions, manage home directories. It's also pretty straightforward to switch from HTTP to HTTPS and to block people not on the local network from accessing the NAS's web interface. He said, all in all, I like NAS for free. It's a good general purpose NAS operating system. While I did not feel the project did anything really amazing in any one category, nor did I run into any serious issues. The NAS ran as expected, was fairly straightforward to set up and easy to manage. He said, this strikes me as an especially good platform for home or small business users who want an easy setup, some basic security, and a solid collection of features. So I think that was a pretty good review he gave there. So
one of the main things that NAS for free has is that they still offer UFS and 32-bit versions. So I know some people with, especially if you have older hardware that you're trying to use as a NAS, which is probably not the best idea, but some people want to do that. And
some people are still trying to do that.
FreeNAS is 64-bit ZFS only, and so if you have smaller hardware and want to use UFS, this is a decent option.
Very, very cool. Okay, well, let's move on to our next story here called BrowseX, Unix in a browser tab. Now, you have to explain this to me because I think I threw up in my mouth a little bit when I was reading this. So help me feel less sick, Alan.
I'm not sure how that works, but this is a project, and its goal is to let you run C, C++, Go, and Node.js programs as processes in your browser tab, including being able to run LaTeX, Make, a Go web server, or your POSIX shell and shell scripts right in your browser.
Yeah, that's a thing. Yeah. Okay.
So it says programs written to run in conventional operating systems typically depend on the OS to provide abstractions like processes, pipes, signals, and sockets. Whereas compiling programs into JavaScript using like ASM.js or WebAssembly or Mscripting or Gopher.js or whatever isn't enough to successfully run most of these programs unmodified because the browser provides a non-traditional runtime environment that lacks, pipes and signals.
Sure.
So they've built this so that you could run unmodified applications directly in your browser. Not necessarily fast, but
sure.
Especially for certain types of legacy applications, this could be an interesting approach. So yeah, it allows you to run unmodified C and C++ programs as processes on web workers executing in parallel with the main browser thread. So you don't have to worry about it running process causing the browser to stop working correctly. So it actually uses web workers to basically run in a separate thread and be a separate process. In particular, what BrowseX provides is a pretend kernel and system call interface. By working at the lowest levels of abstraction, BrowseX provides shared resources to multiple language runtimes, just as a traditional operating system enables running programs written in a host of different languages. And it says, by enabling a larger class of programs, including legacy code bases, to run in browser, BrowseX can free you from the chores of sandboxing or load balancing programs server-side. If you have some, old C program that you need to make available to users, then it's relatively interesting to actually see that happen in the browser. So the first example they have here is a Unix terminal exposing Dash, which is Debian's version of Ash, which is NetBSD's version of the regular Bourne shell.
I'm running it. There's no CD command. This is a problem.
Okay.
But
in their
you have to cat the read.
in their example here, you cat the readme and then pipe it into a while loop, reading one line at a time, and then echo readme : that line, done. So you can see a basic shell script, file system access, and a pipe all happening right there in your browser. And they provide the source code how they did it as well. Then they have an example of running the LaTeX editor, and they have a meme generator they wrote. And so on. So yeah, this is a framework that bridges the considerable gap between a conventional operating system and the browser, enabling unmodified programs expecting a Unix-like environment to run directly in the browser. And they have a little diagram that shows how it works. But yeah, so they provide processes built on top of web workers, which let programs run in parallel and provide system calls like fork, spawn, exec, and wait. They have signals, so you can kill a process. They have a shared file system so that multiple processes can all access the same set of files. They provide pipe support so that you can, pipe this into that, which is important. And they provide sockets, including support for TCP socket servers and clients, making it possible to run applications like databases and HTTP servers in a browser. Why you'd want to run an HTTP server in your browser, I'm not entirely sure.
And you thought your Chrome was slow before.
And thanks to a successful Summer of Code project, they now have an init system that runs in a browser tab and supports supervising in-browser services and supports the systemd init file setup.
Oh, man. Yeah.
So they have a whole paper describing the details of it here if you'd like to get a copy of that. And the downloads for it. There are two parts. The first is a kernel, which is written in TypeScript and basically provides the core Unix features like pipes, concurrent processes, signal sockets, and the file system. And then they have an extended JavaScript runtime that allows it to interpret C, C++, Go, and Node.js and support running those programs written in languages directly in the browser.
So can I run Firefox and then run a copy of Firefox in my Firefox, which then runs something else in Firefox?
I think Firefox might have a few too many dependencies that would use a couple of exotic system calls that this might not provide. But just being able to run shell scripts in a browser tab is quite interesting at this point.
It is very interesting. Anyway,
I bet with a little bit of work, you could run links in Chrome or Firefox.
That's right. That's right.
Just compiling links in Chrome or Firefox would be, startling enough, I think. But
Yeah, this is pretty crazy.
Interesting toy project.
Yeah.
This is from the University of Massachusetts at Amherst.
Okay. Yeah, very nice. Yeah, that is very interesting idea. Wow.
Yeah. I don't know. For like C programs that were written a really long time ago that, still need to go, I could see instead of having to run some old OS, you could just run it in a browser tab on your desktop or laptop.
Sure.
I don't know. That's special.
Well, who's to say you could take that binary and run it, though? Wouldn't you still have to recompile it for the browser? I don't know. If you're going to go to all that work, why don't you just compile it on your operating system? Anyway.
We'll have to see.
We'll move on. I will refrain. Okay, so we have our second sponsor this week we need to get to, which is iXsystems, and the website for that, iXsystems.com/BSD Now. Of course, you'll want to go there and fill in the information, get in touch with the sales engineers. Of course, tell them you heard about it here on BSD Now. That's the pro tip. You see, the secret service. But anyway, now if you contact the guys over at iX, you get the white glove service the whole way through. Of course, they can build anything and everything. So we're talking the little minis that go under your desk, FreeNAS minis if you need some storage, all the way up to just powerhouse servers. And we've seen them do all kinds of stuff. Built Allen's latest using a specific cell processor.
Things that I've bought, the range is like a little short depth 1U for a router. There's literally only this deep and 1U rack mount. And then I've got deeper ones and deeper ones. And then I've got ones where the motherboard is skinny so that the expansion card, there's actually room for 2 cards in a 1U case, which normally there isn't because the motherboard takes up the bottom slot. But this motherboard basically much narrower than normal, leaving room for the 2 PCIe slots turned sideways to actually have free space at the edge of the case.
That's nice.
And then I've bought 4U servers with 36 hard drives in them. And then last week we showed off the new, what do they call it, the Micro Blade, which is a 6U machine with 28 separate computers in it.
Which is a little crazy.
It's like... you could buy a whole rack and fill it with servers and have a cloud, or you could buy one machine and have a whole cloud right there.
And done. Yeah. Which is pretty amazing. And they compare that with their iX rack offerings where you can throw it into the rack and have a bunch of those.
And have lots of machines and then, fill the rest with storage as one big TrueNAS that's high availability. And then all of a sudden you've got everything you need to,
supercomputing in a box, right?
It's crazy. You could use the cloud or you could have on-premise computing, one rack with everything you need in it.
That's right. So get in touch with the guys over at iX. They like a challenge. They like to hear the specifics about what you're trying to do because using that, they can determine what's going to best suit you. So you won't spend money on things that aren't going to benefit you in any way, but maybe spend the money on things where, if you got this class of drive, then that'll definitely help your database performance or whatever.
The number of different types of SSDs that there are and choosing the right one is all, having their expertise is so much better.
Yes, that's the nice thing about them. They have the expertise. You call up or you email and talk to these folks. It's not just the sales guy. We're like, well, I got these 3 models and I don't really know what you do on them, or what's Linux again, or BSD, what's that? Like, no. iXsystems, that's the air they breathe. So get in touch with them today and let them help you and hook you up with whatever your next project is.
It's like you might not think it, but you actually do want a custom machine for every job.
That is right. All right, so tell us about our latest Michael W. Lucas fix, Alan. What's he got here?
So this is actually a book review that Nixcraft wrote about his recent book, PAM Mastery.
Nice, okay. What'd they say?
So they say, Linux, FreeBSD, and Unix-like systems are multi-user systems and need some way of authenticating the individual users. Back in the old days, this was done in a different way, and you basically needed to change each application to use your current authentication scheme. So applications maybe supported 1 or 2, but if you wanted to use something different or new, you had to manually build that support into each of your programs that you wanted to use it. That was, expensive and time consuming.
Sure.
So, before PAM, if you wanted to authenticate all your users against an SQL database, you'd have to write, link in an SQL library and write the code for each different program. And, if they're in a couple of different programming languages, that gets, you're not just copying and pasting a block of code either or making your own library. You're doing something pretty special. So the Open Group led the development of PAM, or the Pluggable Authentication modules, for Unix-like systems. So today, Linux, FreeBSD, macOS, and many other Unix-like systems are configured using a centralized authentication mechanism called pluggable authentication modules. The idea here is if every program uses PAM, then you just need one PAM module for your authentication type, and all the programs can do it. They also made it flexible enough that you can layer these and do multi-factor authentication or multiple settings and so on.
Sure.
Of course, each OS implemented PAM slightly differently, so a book that covers all of them and helps you bridge the gaps will be quite useful. So the book starts with basic concepts about PAM and authentication. You learn about multi-factor authentication and why use PAM instead of changing each program to authenticate the user. The author went into great detail about why PAM is useful for developers and sysadmins for several different reasons. And the examples cover CentOS Linux, like Red Hat and so on, Debian Linux, like Ubuntu and so on, and FreeBSD. He says, the reviewer says, I like the way the author described PAM configuration files and common modules that covers everyday scenarios for a sysadmin. PAM configuration file format and PAM module interfaces are discussed in easy-to-understand language. The control flags in PAM can be very confusing to new sysadmins. Modules can be stacked in a particular order, and the control flags determine how important the success or failure of a particular module is. So if you watched Michael Lucas's talk from BSDCan or some of the other ones he's done, you can see it's actually, you can have multiple authentication modules, and then the flags determine if, okay, this one succeeded, we don't have to, we can stop, and that's good enough and keep going. Or we can say, if this one fails, we need to stop, but otherwise keep going. Or maybe say, so first we check, does the person have a Google Authenticator? If no, a failure there doesn't necessarily mean we want to stop. We want to try the next thing. Or maybe we do want to stop, right? And there's all these combinations. You can layer them and do really interesting things.
All kinds of stuff.
But, without the book to guide you through it, you might very easily get lost. And the book also highlights some of the misconceptions. Like, it looks like if you do this, it'll end up being this way. But actually, what you will do is make it so you can never log in, or so that anybody can log in.
It's very secure then.
He says there's also a chapter dedicated to using one-time passwords like Google Authenticator. And the final chapter is about how to enforce good password policies for users. So requiring minimum strength and forcing changes and all that other type of stuff that you might be required to implement by your company's security policy. He says the sysadmin would find this book useful as it covers a common authentication scheme that can be used in a wide variety of applications on Unix. You will master PAM topics and take control over authentication at your organization. If you use Linux or Unix type things and a sysadmin, I highly recommend this book. Once again, Michael W. Lucas nailed it. The only book you may need to do your PAM deployment.
Okay. We have a link, of course, to getting the PAM Mastery book here, too, from his website. So check that out if you want to grab a copy yourself.
Yep. On Michael's website, he has it available in lots of different formats, including being able to get it from Tilted Windmill Press, which is his personal online store, which offers 3 different formats. I think EPUB, PDF, and one other one. What's the other popular one? All of them having no DRM, and because it's non-EU, because of that, if you're in Europe and want to buy it, you can get it from Gumroad. You can also get it in Kobo, iBooks, or Amazon US, UK, Germany, or Canada. Or that's for the ebook versions. There's also print versions available in US, UK, and Germany.
Okay.
So if you prefer a print copy, then you can get that as well.
Fantastic. Okay, so you had teased us about this story a little bit earlier because it was mentioned, I think, in one of the first or second stories. So tell us about what Ken Thompson wrote about reflecting on trusting trust.
Yes. So this is a article that Ken Thompson wrote in the Communications of the ACM, Volume 27, Number 8, in August 1984. So this was like a month before I was born. In a paper entitled Reflections on Trusting Trust, Ken Thompson, the co-author of Unix, recounted a story of how he created a version of the C compiler that, when presented with the source code for the login program, would automatically compile a backdoor into it that would allow him to log in by just typing in a certain password.
That's
of course, this
good.
is only half the story, though. In order to hide that Trojan, because it would appear right in the source code of the C compiler, right? Ken also added this version of CC, the ability to recognize that CC is compiling CC and inject the backdoor into CC, so that the backdoor CC would then be able to compile login with the backdoor. If you didn't quite follow that, I'm going to go into a little more detail in a second here.
Okay, good.
Yeah. So, starts off, and he says that the C compiler is written in C. Or sorry, he starts off by looking at a little programming contest, which was to write a program that writes itself.
Sure.
Right? Or actually, in this case, it's a C program that writes a C program that writes itself. And he says this is, a very interesting thought experiment and cool way to learn about programming. But he says the C compiler is written in C. What I'm about to describe is one of the many chicken and egg problems that arise when compilers are written in their own language. In this case, we use a specific example of the C compiler. So the problem with the fact that C is written, has to be compiled in the C compiler, is that how do you compile a new version of C in the C compiler if it adds a new feature that the old version of the C compiler doesn't know about, and then you can't compile the compiler?
Sure.
So he says, suppose we wish to alter the C compiler to include a new sequence /v, right? So we have escape sequences built into C, like /n for new line and /t for tab. Well, what if you wanted to add /v for a vertical tab?
Okay.
So he shows a little example of the code, but when you run it, it will crash because the C compiler that isn't updated yet is trying to compile the new C compiler, and it's encountered an escape sequence it doesn't know about.
Sure.
And so you can't compile your new C compiler because your old C compiler doesn't know about the new feature you're trying to invent. So instead of returning /v when it finds the v, it then returns the raw character code, 11, for a vertical tab. So then using that, he can compile his new C compiler. And then using that new C compiler, he can then compile a new C compiler that actually understands /v and eventually get to the version of source code where /v actually works. And anyway, he goes through that in some detail as background to what we're actually going to get into. So then he says, the actual bug I planted in the compiler would match code with the Unix login command. The replacement code would miscompile the login command so that it would accept either the intended encrypted password or a particular known password only known to Ken Thompson.
Sure.
Thus, if this code were installed in the binary and the binary were used to compile the login command, I could log into the system as any user that way, right? So he made a change to the source code of the C compiler so that when the C compiler notices that it's compiling the login command, it adds a bit of code so that if the password you entered was, Ken Thompson or whatever, it would let you in no matter what the actual password was. So he added this code to the source code for the C compiler and then, compiled it and used it.
Sure.
Yes, he says, such blatant code would not go undetected for long. Even the most casual perusal of the source of the C compiler would be like, why is there this bit of code that detects that we're compiling login and adds this backdoor, right? So next,
that makes no sense. Sure.
He simply added a second Trojan to the one that already existed. The second pattern is aimed at the C compiler itself. So when CC detects that it's compiling CC, it injects the backdoor into CC of, if you're compiling CC, add the backdoor, and if you're compiling login, add the backdoor. So the replacement code is a stage 1 self-reproducing program that inserts both Trojan horses into the compiler. This requires a learning phase, as in stage 2, the example. First, we compile the modified source with the normal C compiler to produce a bugged binary.
Yeah.
We install this binary as the official C compiler. We can now remove the bug from the source code of the compiler and compile again. And now the new binary, while the source code doesn't say anything about the Trojans, this compiling a clean version of the compiler with the bad compiler will now give you a compiler with the backdoor whose source doesn't contain the backdoor.
Oh, okay. Yep.
Yep.
Oh.
So we can now remove the bug from the source of the compiler, and all new binaries will have the bug inserted in them whenever it is compiled. Of course, the login command will remain bug with no trace of its source anywhere either, right? Because we never modified the source of the login command. We just modified the source of CC. But we added a second backdoor to CC to backdoor itself to keep adding these two backdoors to every successive version. So now there's a Trojan version of CC. If you compile a clean version of CC using the bad CC, you'll get a new bad CC. If you use that bad CC to compile your login program, it'll have the backdoor. The source code for both CC and login is perfectly clean and contains no backdoors. You can audit the source code all you want. It's completely fine.
Sure.
But as long as that way back, because every version of CC has to be compiled with some version of CC, as long as the first one had the backdoor and added it to the next one, the backdoor will always be there. Even if you use CC to compile a brand new CC and then use that to compile another new CC, it's always going to keep propagating the backdoor. But the code for it doesn't even exist anymore. Yeah, so the compiler you use to compile your new compiler is the untrustworthy bit, but you have no way to know that it is untrustworthy, and no way to make a new compiler without using the bad compiler. At some point now we have binary packages, so you can bootstrap and get a compiler to compile your first compiler with. But this is a big step in the development of, say, Clang was when Clang became self-hosting. That is, Clang was able to compile Clang. Because originally you had to use GCC to compile Clang, because how else are you going to do it? But he says that the moral of the story is obvious. You can't trust code that you did not totally create yourself, especially code from companies that employ people like me. No amount of source level verification or scrutiny will protect you from untrusted code. In demonstrating the possibility of this kind of attack, I picked on the C compiler. I could have just as easily picked on any other program handling program, such as the assembler, the loader, or even hardware microcode. As the level of programming gets lower, these bugs can become harder and harder to detect. A well-installed microcode bug could be almost impossible to detect. So imagine your CPU in its microcode has a little bit of code that says, hey, when you're compiling the login command, inject this static password as an accepted thing. And then it's like any code compiled on this computer will be untrustworthy.
Oh, man.
Yeah, don't think about that one too hard. It'll give you nightmares.
Let me go find some foil. I need to make a hat here really quick because I'm feeling really paranoid now.
And at the end, he also has an acknowledgement. He says, I first read of the possibility of such a Trojan horse in the Air Force's critique of the security of an early implementation of Multics, which is the operating system that came before Unix. He says he couldn't find the specific reference to cite it in this document, and he'd really appreciate it if anybody could send him this reference. I'll remember that he said that in 1984.
Wow. So has people's minds been blown today? Because that's pretty creepy, man. Thinking about that. So what's the answer here? Do we have to go fuzz and change all the source code so it can't do the pattern matching and know that it's compiling login or SSH or whatever?
Well, the problem is you're going to compile that new code that has the fuzzing with which compiler?
Well, the bad compiler, but the bad compiler is still looking for specific things to key off of to say insert the code here, right?
Yes. Although, since 1984, we might have come up with better ways of detecting that.
Sure. Change all the things.
Yeah.
Change it all.
This is why reproducible builds are important, where I can start in my clean room box with a compiler I got from somewhere that you didn't have control over and compile all of the things and hopefully end up with the exact same binaries you have, and then I can know that I can trust the binaries I can have some trust in the binaries of your thing. I'm not sure anybody can have full trust in anything ever.
Trust nobody. Wow.
Yep.
Okay, well, good. Thank you, Alan. Now I will not sleep tonight. Appreciate it.
Yep.
Okay, time to head over to Beastie Bits here. So we got a few things to cover. So first up, something really neat. It's time for Christmas shopping. And who doesn't want a FreeBSD Beastie Christmas stocking? I mean, how cool is that? I assume you're showing the picture there, Alan, but yeah, that's really neat. I think everybody needs one.
Yes. A BSD user wrote in and said they're very creative significant other has created these BSD themed stockings. So they're meant to look like the green shoes that BSD wears, and then they got the little trident attached and everything. And you can go over to Etsy here and buy them. I would recommend hurrying up because they probably can only make so many in time for Christmas. And so you probably want to get going on that.
That's right. Yeah, put your order in early. Otherwise, it probably won't arrive till next year. Yep. But anyway, take a look. That looks amazing. Okay, so next up we have a little walkthrough just how to migrate ZFS from a mirrored pool to a RAID Z1, which revolves around doing a send and receive and recreating the pool and whatnot. Just wanted to pass that along as a reference.
Yes, in particular,
asked a lot.
One of the things they have here is they've come up with a basic algorithm for figuring out how much space it's going to take on the RAID Z1. It's slightly more complicated than the formula there because of padding. It ends up depending on the block size. Because in RAID Z, your allocations always must be n plus 1, where n is the RAID level. So Z1 is 1 plus 1, so it means every allocation must be an even number, 2 blocks. On a RAID Z2, it means every allocation must be of 3 blocks of the block size, which on most newer drives will be 4K. So what that means is if you try to write, say, an 8K file to a RAID Z2, because the allocation has to be divisible by has to be in groups of 3, it means that to do 2 blocks plus the 2 blocks of parity, that's 4, but you have to round up to 6, meaning that 2 blocks get wasted as padding. It'd be worse if they didn't, though, because you'd have these 2 blocks left, but if every allocation of one block would be 1 block plus 2 parity is 3, that won't fit in 2 blocks. So you'd end up with space that looks free until you go to use it, and then it's like, oh, it's actually not big enough for me to put all this data together. So your block size can have a big impact on how much space stuff takes. So moving mirrors of, say, VM images that are all done in 4K or 8K over to RAID Z could end up taking a lot more space than you expect. Whereas if your files were all 128K chunks, moving it over probably won't make that big of a difference. But if you want to know more about the padding and allocation and so on, then you should check out the advanced ZFS book where it's described in detail. But yes, cool. This is basically using send receive and a little bit of math to figure out how much extra space you need to be able to fit everything on the new pool and so on. Okay.
Well, next up, we have slides from OpenBSD and you. It looks like Peter Hanstein gave a talk here at BLUG, which was in Bergen. And this happened about 3 weeks ago. But we have all the slides online. I'm not sure if there's audio or video anywhere, but at least the slides look pretty cool. So if you want to take a look at that, this is all updated and current with OpenBSD 6.0. So he has a lot of good information here. Check that out if you're interested. And then what's our next one here? We have, it looks like Robert Watson has something, a cross-reference.
Yeah. Our producer found OpenGrok, which is a source code browsing thing. And so I also pointed to Watson. So there's FXR, or FreeBSD cross-reference, .watson.org, which is a website that has each different version of the FreeBSD kernel. You can see, 12, 11, 10, 9.2, 9.1, 9.0, 9, 8, 7, 6, 5, 4, 3, 2, etc. Then it has a couple of branches from Linux, although those are a little old now. I know he's working on updating this, but they need more hardware to fit the data. They're basically out of disk space for adding more stuff.
Okay.
But it allows you to search and cross-reference source code for FreeBSD, Linux, Plan 9, Mach, Apple's Darwin, OpenSolaris, Minix, NetBSD, OpenBSD, and Dragonfly, and find the history of source code and where it all came from and how it's changed and so on. And it's quite useful, and I look forward to when he gets around to updating that to support more versions of Linux and so on. In particular, he says it was quite useful to him as a way to find bits of code and to allow him to navigate and understand the Linux kernel when he was trying to port things like help port things like Capsicum over to Linux.
Okay.
And then here we have
Very nice.
bxr.su, which is a version of OpenGrok that allows you to search the Dragonfly, FreeBSD, NetBSD, and OpenBSD trees.
Okay, so next up we have a couple. We have an essay we wanted to bring along. It looks like a 26-plus-year-old bug was found in BSD's libc. Likely all the BSDs are affected.
Yeah,
of course,
so
going back that far.
This goes back to the original just BSD before there was NetBSD, OpenBSD, FreeBSD, Dragonfly BSD, HardenBSD, TrueOS, etc. There's in the function link_n to a, which generates an ASCII representation of the link level address or your MAC address. And it's part of libc. A specially crafted argument can trigger a static buffer overflow in the library with the possibility to rewrite the following static buffers that belong to some other library functions. So this is due to the very limited use of this function in the existing applications and limited length of the overflow, exploitation of the vulnerability does not seem very feasible. None of the utilities and daemons in the base system are known to be vulnerable. However, careful review of third-party software that may use this function was not performed.
Okay, so there could be things that use it. So just to be on the safe
you should
side,
definitely fix it anyway.
Okay.
And then we have a follow-up. HardenBSD, while reviewing the patch, noticed that it seems that the patch miscalculates how much space is left in the buffer by adding to the number of remaining bytes instead of removing from them as it's doing the work. And that could end up not fixing the vulnerability in that particular
case. So we'll have
case.
a follow-up patch to the patch.
Yes, we'll expect an update to the essay probably in the next couple days.
Nice. Okay. Well, cool. Well, also some info we wanted to bring you. December 27th until the 30th, the 33rd Chaos Communication Congress is going to take place in Hamburg, Germany, which, of course, you could kind of picture that as a gathering of European hackers, overseas friends all showing up. So I guess you're organizing something there, Alan?
Not me, no.
Okay.
Sorry, this is from an email. So if it says
I was going to say this. Yes. One of our users who wrote in, or listeners wrote in, said they're one of the people organizing the BSD assembly, and they have a link here to the Assembly BSD event. So if we have any BSD enthusiasts and want to go there and wave the flag amidst some of the other projects, please do so. Get in touch with them and see if you can make your way out to Hamburg, Germany. Okay, well, we need to go to our next sponsor this week, which is going to be Tarsnap. Website for that, tarsnap.com/BSD Now. Now, if you were paying attention on the show, we talked about Colin Percival did the BSDpatch, that's saving the petabytes and petabytes and petabytes of information traveling around the internet. Well, Colin is also the guy behind Tarsnap. So math wizards, they come up with really cool stuff. And he wanted a good way to back up his data to the cloud safely and securely, but not allow other people, nefarious individuals, groups, governments, etc., to be able to possibly look at that information up in the cloud. So he came up with Tarsnap, which does everything properly, where it encrypts the data locally on your box before a single byte of it or anything goes out over the wire and ends up on the internet. So you're in control, complete control. As long as you have your key, you have access to your data. Throw that key away, and your data is as good as gone. Now, of course, he doesn't just claim that. He backs it up, of course, because it's Colin. He has the source code posted. So if you want to audit it, take a look, verify it's doing exactly what it's supposed to do, you can do that. And then, cool, if you're really paranoid, you can even compile it yourself. Although hearing that compiler story today, Alan,
just
I can't compile anything.
Make sure that your compiler came from somewhere that isn't interested in your Tarsnap backups.
That's right.
What's interesting is obviously Tarsnap actually uses something similar to BSDiff for its deduplication. So it's actually doing this to your blocks before it sends them to find to make the data as small as possible. So when you're uploading your diffs for your backup, you're not wasting bandwidth uploading stuff that's already there.
You've been using Tarsnap for a while. You've already beaten the entire Android community to the punch, and you've been doing this form of deduplication way ahead of time. So definitely cool stuff. And of course, if you go to the website, get signed up, make an account, you'll be pleased with how easy it is. It has the word tar in there because it's a very tar-like interface, so super simple to use. I have a tar background, so it was like, 20 seconds and I've got this. Anyway, take a look today, get signed up. I know me and Alan have been using it for quite a while, and I think you will be pleasantly surprised as well. Okay, so we got our first feedback question this week from Chris, who sends us an email. He says, "Good morning. Thanks as always for the podcast. I've built a router based on the blog post Chris made last Christmas." He said, "Mine's slightly different because there's a wireless NIC built in I'd like to use." He said, "I've got everything working except the firewall. With just one interface enabled, everything works fine. As soon as I try to include the Wi-Fi, the firewall blocks everything using rule." And then he has the number here. He included some links to rc.conf and IPFW rules. And he mentioned that WLAN 0 and Bridge 0 are commented out in the paste, but it doesn't work if they aren't commented out either. Let me look at the rules here, Alan. Have you taken a look yet?
Yeah, I'm just pulling them up now. Did he say which rule was blocking things? 550.
0550. So let's go take a look here. So, of course, that's the deny log all from any to any. So that's the last rule there. So he says, but as soon as he tries turning on wireless, everything gets blocked.
I'm guessing it's... Now, he mentions that he has a bridge. Packets end up passing through the... there's a sysctl that controls it. I forget what the default is. But packets end up going through the firewall twice if they're on a bridge. Although I think the default is only once, right?
The default is once, but you need to enable it so it can go through multiple times.
Well, that's only if you want to block it on the bridge, right?
Well, I think you still need it on, though. Or I think I had it on my server, actually, because I ran into a similar problem. Let's see.
Yeah, I've not tried to use a bridge for this. Of course, what? Oh, you skip location. Okay, that's after that.
Of course, now I can't remember what the parameter is.
Any allow rules for that interface.
Yeah. You're not allowed anything through.
Yeah. It looks like you're missing a rule to actually allow things.
It's ip.fw.1_pass equals 1, right. I believe. So you could mess with that if it's trying to go through twice.
But in particular, I don't see a rule that's supposed to be allowing anything.
Over the wireless device? Let's see. So he is set up.
Yeah, I don't see anything mentioning the wireless, although the wireless is probably internal. And so, yeah, if you uncommented that line 19, that would help there. But, I don't see a rule that's allowing stuff out over the internet.
Let's see. So his IGB1, it looks like, is what's going out to the net, I assume?
No. PIF or IGB0 is the internet, and IGB1 is the LAN.
Okay. Yep, I see it.
So I see allow all on IGB1, which is his LAN, which makes sense. Mm-hmm. But I don't see something that actually allows a connection outbound.
You are correct. Yeah, I don't see that either.
What's $skip?
No, he has allow all outgoing packets. Skip all from any to any out via PIF. Keep state.
And then he does the NAT.
Yeah. Well, we have links now posted in the show notes here. If other folks would like to take a closer look at this, we may not be able to debug this one on the fly.
Not live on the show, sorry.
No, yeah, it's... just at first brush, it looks good. But anyway, I have to compare it to my rules and see. Although I'm now using PF because I needed UPnP. Anyway, long story. We can hear me complain about that later. Anyway, okay, well, let's move on, I guess. Yeah, so Chris, we'll try and we'll post it. Maybe somebody has comments, and if we get any emails or comments from others, we'll pass it along. Okay, so Jason writes in next. He said, I'm looking at building a NAS to store my movie collection to serve off of ZFS. I was thinking of either using FreeBSD 11 or TrueOS server versus a FreeNAS install, as I was thinking of using a Beehive VM as my MB Kodi box, as well as the VM to do any transcoding that needs to happen offline when we're not watching movies. He said the NAS will live right next to my main TV, and I was thinking about why set up a NUC or media PC here when I can just put an NVIDIA card into it and connect it to the TV. How mature and how well does the PCI pass-through work in Beehive in 11 or TrueOS?
For graphic card, it doesn't yet.
Yeah, you're kind of out of luck there. He said, I'm an advanced user, so I know how to run FreeBSD and ZL with CFS pools, so I don't need the FreeNAS interface to manage the box. He said, I never used Beehive yet. But yeah, as Alan said, PCI pass-through of the graphics does not work yet.
But people are working on that now.
Coming soon.
Yes, hopefully.
Yeah, we will all be very excited when that goes in, because there's a bunch of us who want that for different things. So,
my solution was put the NVIDIA card in and run TrueOS, and then I have like VLC and the file system browser, and it's like, go to the thing I want to watch and click on it.
And then it does it.
Yeah.
Right?
Now, I'm guessing you want something like MB in the front end where you can do it with the remote control or something, and, maybe you want to do that. I don't know.
Well, he could run that right on the host. Yeah. I mean, if he's running TrueOS, so that's doable. Yeah. You don't have to
put the just use TrueOS pass-through and the graphics card natively instead of having to do any pass-through at all, if you want. Yeah. But if you want to use Kodi and MB, in particular, there's a Plex plugin for FreeNAS, and Plex now has a Kodi front end or something.
I don't even know anymore.
There's some way to do it all
with Plex
together, and it works very nice now, apparently. Okay. This is like new as of last week.
Sure. All right, I'll let you read the next one, Al.
Yes.
I get the first two.
So Al's writing in about PF errors. He says, thanks for the help with the FreeBSD upgrade from 10.2 to 10.3 on DigitalOcean. It worked a treat. Glad it was able to help. He says, I tested it first by using the snapshot feature provided by DigitalOcean, which works really well. I shut down my live droplet, took a snapshot, powered it back on, created the new temporary droplet from the snapshot with a new IP address, connected to it, made sure everything was working as expected, performed the upgrade, everything worked perfectly on the temporary droplet. So in my next maintenance window, I created a new snapshot of the live droplet and then ran the upgrade on the live droplet, and it worked great. And, if it hadn't, he could have gone back to the snapshot.
Sure.
One thing I've noticed, but this was happening for the upgrade, I'm using PF as my firewall. It works great if you manually start it, but I've noticed that after reboot, the PF service is not started. But since the system has booted, you can log in and start PF manually. He says, I have PF _enable enthusiast in rc.conf. In the logs, I see no IP address found for DNS hostname. Error on etc firewall line 23, could not parse host specification.
Sure.
And then he gets PFCTL syntax error in config file, PF rules not loaded. I'm guessing is because on line 23 in your firewall rules, you have a rule that has a hostname. He says, I have a couple of rules which look up hostname to match firewall rules. So it looks like that DNS resolution has not started yet when PF is trying to start, and then it fails with the thing, and I change the rules to match an IP address and reboot. The server PF starts correctly. I'm trying to move the PF lines to the end of the rc.conf file in case... no. So the rc.conf is a config file. It's red, and it's not order specific. You'd have to edit etc rc.d pf and set it to depend on
whatever provides DNS.
Well, in particular, on a DigitalOcean droplet, your IP configuration comes from like Avahai, not DHCP or something. So you'd want it to happen after that.
Yeah, or the easy button would be put it call an RC local that waits for so long and then just starts it again.
Like RC.local will be done at the very end, and so it'll probably be late enough right there.
Yeah.
So just,
that's where I would put it.
etc rc.local and just have service PF start.
And that won't get blown away the next time you upgrade.
Yes, unlike the RC.d
you modify
stuff.
etc PF or RC.UPF, that'll go away. So okay, well, cool. Hopefully that helps you out, Al. Okay, so the next one is Zach, and this is a pretty long one.
Definitely your area, not mine, though.
Yep, I will read this one here. He said, well, guys, I've been watching for a while now and love the show. Suggestion, he said, we add Brian Cantrell sound bites to a soundboard for amusing rant clips. That could be funny.
I'm not a huge fan of soundboards because certain other podcasts ruined it, but anyway.
Oh, okay. He said, I really want to run FreeBSD on my AMD hardware with graphics desktop. He said, I have an AMD A10 7700 or 7700K APU, I guess Cavalry. I'm not up with all the AMD stuff, sorry. But he said with a Radeon R7 graphics, and then he has an Asus blah, blah, blah motherboard. When I check the TrueOS status page, it says that AMD graphics aren't working yet. So he said, I have a fresh install of FreeBSD 11 that I'm working with. There are no additional cards here, just what comes on the board CPU. The FreeBSD graphics says that the R7 is supported. He said, I think. He said, I have added the Radeon KMS to the KLD list. I have installed X with Mate Desktop as the handbook recommends. However, X still fails to start. He said, I will add the docs suggested in a follow-up when I get home. He said, Slim starts but fails, still no X. He said, I have not tried Visa or SCFB yet. My question is, am I reading the docs correctly? Should my graphics be supported? If not, do I need to buy a discrete GPU and disable the onboard graphics? And if I have to use Visa or SCFB, which is better in quality? I prefer SCFB personally, but he said the most demanding thing I do graphics-wise is watch YouTube and play a little Minecraft with the kids. FCFB could work for that. You won't. The Minecraft stuff won't work very well because 3D rendering and software sucks. But watching videos isn't so bad. He said a couple doc suggestions for the FreeBSD Handbook Xorg section. He said, I've read through it a couple times, haven't seen where it says you need to load the kernel module for your particular graphics driver. He said the handbook also seems to disagree with the graphics wiki page where the driver should be loaded in bootloader.conf versus rc.conf. He said, what is the right way, please? So in TrueOS, we've defaulted to loading them on rc.conf now because we found a few edge cases where loading them in loader.conf. You can run out of memory in EFI. I think that's getting fixed now, though, or has been already. But also, we'd seen some panics when it was loaded in loader.conf, and loading later with rc.conf seemed to work better.
If you can load later, it's much faster as well. Yes,
it is. So we've switched to doing that. So KLD list. And it's not so much that the handbook disagrees. I think it's just outdated, to be honest. I think someone needs to update that section. But he said, I remember Alan saying that people were working on some aspects of the FreeBSD installer, and I've seen the security options there. I think it's a good step. I wonder if it's possible to add an appropriate section for GPU or hardware graphics where it's detected to make the user make a choice regarding loading the appropriate graphic modules at boot. For example, installing Xorg, TextX11, if working, save the config. If people don't want it in the installer, maybe a post-install option just above open a shell or make some additional changes. I don't know, Alan, if you guys want to go that far.
I have a patch.
TrueOS does that.
I have a patch that adds an option to the end of the installer to add KDE, GNOME, or XFCE and have them like start as the login manager if you enable them, basically. So you pick one and it makes it start X by default if you choose one of them, and does a very, very basic configuration. Configuring graphics is much more difficult.
It's very tough.
Yeah.
And we've been doing it for a long time, and it's not pretty. I'll just be honest. There's a lot of things that can go wrong, a lot of edge cases. Like you said, this particular chip doesn't work great, right? So, and if you load it, we've seen some cases where if you load it with the wrong module initially, like if you're doing an auto detect, you can actually lock the box up. Like there's just all kinds of little things that just are weird.
Yeah, and I was having trouble with a login manager, I think, for XFCE, getting one that would work. When I tried Slim, it wouldn't start XFCE for me. It would just give weird errors and wanted a certain file to exist that I didn't want to have to create. And yeah,
it's messy. Yeah. It's difficult stuff. So let's say we try and do it on the TrueOS side. I would actually try TrueOS. I don't know if that card specifically is supported. If it's not in FreeBSD, it may or may not be in TrueOS yet. It just depends on
I don't think
whether
Radeon's very far yet, is it?
Yeah, I don't think so. I mean,
there was honestly, a post on the graphics list recently from Matt Macy detailing where things are currently.
And he is going to be doing some more work on the AMD side here in the near future. So maybe it gets better. My personal recommendation is you're on a desktop. It's not a laptop. You go buy a $30, $40 NVIDIA card. Toss it in the box. Load the driver. Problem solved, right? Then you'll get the acceleration. It's good enough to play Minecraft. You don't need a really big GPU to do that. And it'll be fine for YouTube. That's what I'm doing for my desktops. And then, of course, Intel on the laptops. But I think that'll just save yourself some time and headache, personally. Let's see here. He said, if you want people to run free or TrueOS on their daily driver hardware, this would be a good step to at least give them an option to configure the driver and test X. So again, we have that in TrueOS. Our first boot and our installer has options to pick different drivers and test, and then it saves that, and we'll use it going forward. So yes, TrueOS already does that. But he said one other bit of feedback. He said it's more frosting on the cake for my own use case, but he said, could there be an installer menu that allows you to change some of the defaults in Etsy default? He said change the system default from Pi 2 to Pi 3 or whatever. I don't know. Would you want that, Alan? Like, I don't know if that's necessary or not. Like, yeah, I don't know how you. Well,
those
changing
defaults,
the Python version.
That's set in
the port tree.
etcmake.conf and applies to the port tree, but that doesn't really work for packages. The entire repo has to be configured that way, and then as you get, say, 10 of those settings, now you have 1,000 different repos.
It gets
it doesn't work that way.
Yep. He says, though, thanks for the great show, the awesome OS, and the support and answers you've given me. He did say he participated in Michael Lucas's ZFS talk, though, at Ohio Linux Fest. So he said he did a really good talk, and he said 10 out of 10, he would suffer through it again.
Well, in particular, he says he volunteered out of the audience to attempt to grab Michael Lucas, who then quickly applied a painful joint lock. He says, as a holder of 2 first-degree black belts, I can confirm that Michael is very good at that.
Yeah, well, it's good to see. So, yes, if you get a chance to see Michael W. Lucas live, you should do that. It's always a treat. Or just come over to the
don't volunteer for anything.
Yes, don't volunteer. Okay,
unless it's
so
gelato.
The next one. Yep. So our last one here, we have Bart writes in. He says, hi, Chris and Alan. I'm a big fan of FreeBSD. I tried putting it on every device I have. Sadly, it often stays with an attempt. He said, last year I tried installing FreeBSD 10X on my laptop, but it had no support for my wireless card, which he said was a Realtek 8723 AE. He said, I tried a FreeBSD 11 daily build, and that one had support.
There we go.
He said, I didn't keep the install long because it was a daily build and I needed my laptop for school. He said, yesterday I tried FreeBSD 11 again, but now my card isn't supported again somehow. He said, is there a way for me to figure out where my driver went or why they removed it?
I doubt it was removed. It might be that the firmware's not loaded. I would try a TrueOS build just because it has more of those things turned on by default.
Yeah, we have all those knobs switched
and
on.
It's
check
easy enough
maybe
to
the kernel
try
module
it that way.
Yeah, maybe the kernel module wasn't loaded, or like Alan said, there's a firmware you're messing. But I doubt it would have gone away if it got put in. He said, if all else fails, though, is it possible to run drivers through the Linux compat layer?
No.
The
Linux compat layer is only for applications. There's a separate Linux KPI layer for porting drivers, but that's very advanced.
That's a different thing. And he's asking how difficult it is to port a Linux driver. Well, it takes some work, but that's what the mailing list and IRC are for. Jump on, and if you have some experience and like to help out there's always plenty of drivers to port.
Yes. I'm always looking for people willing to do that work.
I'm sure Adrian would love to have somebody else helping with wireless drivers. So, okay, well, that wraps up the show for this week, folks. So, of course, I will remind you, same as we always do, feedback at bsdnow.tv. That's where you want to send all your stuff. Yes. So if you want us to see it and you want us to talk about it and mention it on the air, send it to feedback at bsdnow.tv. Yes, we use Twitter and we do other things, but that's not the preferred way, and we can't guarantee we see all those. So try and send it to that email so it goes to myself, Alan, and JT, and we all get a copy. Of course, if you have questions or comments, you have a show idea or topic or a story, and particular stories are good because sometimes people find things that we wouldn't normally find in our daily searching. So send that over as well. We'll try and get that into a future episode. But of course, we thank you guys for all being here this week and look forward to speaking to you again next week, same time.